are countless variations of stainless steel, or stainless steel that you could potentially use for a custom wire tray or basket. Each stainless steel alloy formulation possesses its own unique properties for melting point, tensile strength, and corrosion or oxidation resistance. Picking the proper stainless steel grade requires knowing what your options are. To help you better understand your choices, here's a quick explanation of the most common varieties of stainless steel and their individual properties. Number 1. Austenitic stainless steels. The most frequently used austenitic stainless steels tend to have a higher amount of chromium compared to other steel alloys, giving them a higher resistance to corrosion. They're also generally non-magnetic alloys, though cold working can change that. Number 2. Ferritic stainless steels. As their name suggests, these stainless steel alloys are magnetic. They're also the second most common stainless steel after austenitic varieties. Manufacturers can harden these alloys using cold working techniques. Ferritic stainless steels are often less expensive as well due to the reduced nickel content in their makeup. Number 3. Marcinetic stainless steel. This is the least common category of stainless steel alloys. The corrosion resistance of austenitic and ferritic alloys is typically higher, but marcinetic stainless steel possesses a high hardness. These alloys are often ideal for applications necessitating exceptionally high tensile strength and resistance to impact. When an application also requires resistance to corrosive substances, marcinetic stainless steels are usable once they've received a polymer coating for enhanced surface protection. Number 4. Duplex or ferritic austenitic stainless steels. The stainless steel category gets its name from the material's composition, which is half austenite and half delta ferrite. With a higher tensile strength than typical austenitic varieties, duplex stainless steels express better resistance to corrosion and chloride pitting. Given their physical properties and resistance to chemicals, duplex stainless steels are commonly found in pipelines or piping systems for the oil and gas sector, or pressure vessels within the petrochemical market. Number 5. Precipitation-hardening stainless steels. This stainless steel category is made up of corrosion-resistant, durable, exceptionally strong alloys. Manufacturers can treat pH stainless steels to yield strengths up to 4 times that of standard austenitic alloys. They're a common occurrence in nuclear, oil and gas, and aerospace industries. There are numerous grades of stainless steel within each category. Grade 301 stainless steel. The composition grade of 301 stainless steel includes additions of nickel and chromium. It's both ductile and strong after cold working and offers exceptional resistance to corrosion. With such properties, this grade of stainless steel has common applications in drawing, forming, and welding. Grade 302 stainless steel. While it has a similar composition to grade 304 stainless steel, grade 302 contains higher levels of carbon. It's particularly useful for its resistance to corrosion when exposed to chemicals, acids, and solvents. Grade 302 stainless steel is a good material choice for conical compression springs, as well as food processing and kitchen equipment. Grade 303 stainless steel. This non-magnetic alloy is among the best of the austenitic stainless steels regarding its machinability. It isn't hardenable through heat treatment. Also, while not as resistant as grade 304, this stainless steel variety is a corrosion-resistant metal. The grade is applicable for gears, shafts, screws, nuts, bolts, and other heavily machined components. Grade 304 stainless steel. The most common stainless steel type, grade 304, is one that Marlin Steel uses often in our custom wire baskets due to its versatility. Even compared to steel alloys, grade 304 stainless steel is notable for its impressive tensile strength, which is about 621 MPa, or 90 KSI. Similar to other stainless steel varieties, Grade 304 has a high maximum operating temperature of about 870 degrees Celsius. Combining high tensile strength with corrosion and temperature resistance makes this stainless steel grade perfect for myriad applications. Grade 309 stainless steel. This nickel chromium alloy shares grade 304's machinability with high tensile strength and resistance to chemicals and high temperatures. Grade 309 stainless steel is commonly found in everything from furnace parts and oven linings to automotive exhaust components and aircraft engines, as well as other high heat applications. Grade 316 stainless steel. Another common austenitic stainless steel, grade 316 stainless possesses a range of benefits with a 579 MPa tensile strength and a maximum use temperature of approximately 800 degrees Celsius. While its tensile strength and temperature tolerance are lower compared to grade 304 stainless steel, grade 316 stainless exhibits superior chloride resistance to substances, making it an ideal option for marine applications or projects that involve salt exposure. Grade 317 stainless steel. Like the previously discussed austenitic stainless steel varieties, grade 317 stainless steel has high corrosion resistance and tensile strength with its high composition of chromium and nickel. However, the alloy also includes molybdenum, which enhances its pitting resistance against chlorides. By avoiding pitting, this grade is great for the marine and chemical processing market sectors, though it does come at a higher price compared to the similar stainless steel options. Grade 321 stainless steel. With added titanium in its composition, non-magnetic grade 321 stainless steel can better withstand high temperatures and chemical-induced corrosion. The alloy can also resist oxidation in environments up to 1,500 degrees Fahrenheit and retains its strength in cold temperatures. The material's properties regarding stress ruptures exceed those of grade 304 stainless steel. Grade 347 stainless steel. The makeup of this non-magnetic stainless steel alloy includes tantalum and columbium, so it's better able to retain its durability when exposed to high temperatures. It's perfect for applications like welding, where there will be intermittent heating in the 800 degree Fahrenheit and 1650 degree Fahrenheit range. Somewhat ductile, grade 347 can be stamped, drawn, and spun as needed. 405 stainless steel. With less resistance to corrosion than grade 430, stainless steel grade 405 is better suited to environments that are only mildly corrosive. With additional aluminum in its composition, this alloy won't harden when cooled post-welding. It's a useful alloy for steam nozzles, quenching racks, and various related applications. Grade 408 stainless steel. Grade 408 stainless steel is highly resistant to heat, but not to corrosion. Contains a combination of 8% nickel and 11% chromium. Grade 409 stainless steel. With corrosion-resistant properties and a tolerance for high heat, grade 409 stainless steel offers particular resistance against atmospheric corrosion and exhaust gas, though it isn't as resistant to corrosion as grade 430. As such, grade 409 stainless steel is common for exhaust systems and similar automotive applications. Grade 420 stainless steel. Of all the stainless steel grades, 420 possesses the highest hardness, up to 50 HRC with 12% chromium. Grade 420 stainless steel also exhibits good corrosion resistance and ductility, particularly when exposed to foods, fresh water, mild acids, or alkalis. It's a common choice for cutlery for this reason, though it may experience pitting if continually exposed to some food compounds. Grade 430 stainless steel. While it doesn't have the strength of the above austenitic stainless steels, Grade 430 stainless steel does exhibit good resistance to nitric acid. It's still sufficiently strong for heavy-duty applications, though its 450 MPa tensile strength, or 65 KSI, is lower than most austenitic alloys. Grade 434 stainless steel. The stronger alternative to grade 430 stainless, 434 stainless has a 540 MPa tensile strength, or 78 KSI. It can handle operating temperatures at a maximum of 815 degrees Celsius. This makes grade 434 stainless steel slightly better for high heat applications than 316 stainless, while being tougher than grade 430 stainless. Grade 434 also has exceptional resistance against pitting when compared to grade 430. Grade 436 stainless steel. A modified grade 434, grade 436 stainless steel has added molybdenum and columbium, which reduces any roping or riding in stretch forming. Grade 436 is fairly resistant to abrasion and very magnetic. Typical usage ranges from automotive parts to appliance trim. Grade 444 stainless steel. Grade 444 stainless steel is a low-carbon stainless steel with molybdenum content that provides good resistance to oxidation and pitting. With properties ranging from high strength to good ductility, grade 444 can be formed with myriad stretch bending processes. That said, the weldability of this stainless steel grade is somewhat limited. Applications best suited for grade 444 stainless steel include roofing and coating in marine environment and food processing applications. Grade 410 stainless steel. A general-purpose marcinetic alloy, grade 410 offers corrosion-resistant abilities that manufacturers can enhance with hardening, tempering, and polishing treatments. Though austenitic steels are more resistant to corrosion, marcinetic stainless steel alloys, such as grade 401, still maintain ideal performance under mildly corrosive conditions. Grade 410S stainless steel. Grade 410S is a low-carbon variation of grade 410. It's non-hardening even under high heat conditions. It will keep its softness and ductility in spite of any rapid fluctuations in temperature, which prevents cracking in high-temperature environments or during welding operations. This stainless steel is often used in petrochemical applications like petroleum refining or thermal processing. Grade 414 stainless steel. This stainless steel is essentially grade 410 with the addition of nickel. This additional nickel content makes grade 414 stronger than similar thicknesses of grade 410. This grade is common in forged shafts, beater bars, spindles, valve seats, fasteners, and other mining equipment components. Grade 416 stainless steel. With machinability of 85%, grade 416 stainless steel offers the highest degree of machinability of any stainless steel. Due to this property and its low cost, grade 416 stainless steel comes in a variety of forms, such as hardened, unhardened, or highly tempered. Grade 416 is less resistant to corrosion than austenitic steels. Grade 416 is less resistant to corrosion than austenitic steels, though grade 416 delivers great resistance against fresh water, alkalis, and acids. Popular applications range from bolts and gears to automatic screw machined parts and washing machine components. Grade 420 stainless steel. When impact resistance and tensile strength are of primary importance in application, grade 420 stainless steel is an ideal choice. Its tensile strength is approximately 586 MPa or 85 KSI once annealed. That tensile strength can increase to about 1,586 MPa or 230 KSI through hardening and stress relieving processes. It doesn't offer the same resistance to chemicals as austenitic and ferritic varieties, but grade 420 stainless steel is sufficiently resistant to food compounds, water, mild acids, and certain alkalis, lending it to applications as cutlery. Grade 440 stainless steel. The high carbon content in grade 440 stainless steel allows for effective heat treating. This enhances its resistance to wear as well as its ability to retain a cutting edge. Grade 440 stainless steel is a magnetic alloy and has average resistance to corrosive substances. Common uses include anything from scissors and knives to components that undergo oil or gas exposure. Grade 2205 stainless steel. Due to its nitrogen content, grade 2205 stainless steel offers impressive resistance to pitting, crevice corrosion, and stress corrosion cracking. This enables grade 2205 to have almost 2 times the corrosion resistance found in other austenitic materials. Marine, petrochemical, oil and gas, and pulp and paper industries find use in grade 2205 in applications requiring significant strength and strong corrosion resistance. Grade 2304 stainless steel. Though it has the same corrosion resistance as grade 316 stainless steel, grade 2304 has nearly twice the yield strength of grade 316 and other austenitic steels. It can also perform admirably in colder environments, though with some exceptions. This material is ideally suited to applications in the range of -58 degrees Fahrenheit to 572 degrees Fahrenheit. Grade 2507 stainless steel. This duplex stainless steel has strong chloride stress corrosion resistance, high thermal conductivity, and a low thermal expansion coefficient. Grade 2507 is compatible with applications requiring high tensile strength and supreme corrosion resistance. Applications that use grade 2507 stainless steel include structural or mechanical components for marine, offshore oil platforms, and petrochemical equipment. Grade 174 stainless steel. This precipitation-hardening stainless steel has both impressive strength and fair corrosion resistance. The degree of strength in grade 174 can be manipulated with heat treatment. It also possesses magnetic properties and average machinability. Common uses for grade 174 include applications in the aerospace, chemical, and petroleum markets. Grade 155 stainless steel. This stainless steel grade boasts high strength and corrosion resistance, as well as transverse toughness, ductility, and hardness capability. It isn't an ideal material for cold working, though it's suitable for hot working. This precipitation-hardening stainless steel is commonly utilized in corrosive, high-pressure environments and is ideal for aerospace parts. Marlin Steel's degreed engineers can create a large variety of wire forms and baskets to meet your needs, including custom S-hooks, swaged pierced wire forms, and I-hooks, among others. These stainless steel forms can be crafted from a variety of the different steel options listed above, depending on your needs and application. Your choice of stainless steel depends on your application, so be sure to contact an experienced mechanical engineer as they can make sure to deliver the best stainless steel solution.